Hello everyone, my name is Aditya Adya, and in this video we will be solving question 5 of homework 2. So in this question, we have a customer flow at a grocery store that can be viewed as a Poisson process, where the probability of customer arriving in 0 to t time interval is equal to k is given by e raised to minus t lambda into lambda t raised to k upon k factorial. Now, suppose the probability that in 2 minutes at least one customer arrives is given as 0.3. So for that probability, we have to find lambda, probability that in 3 minutes no customer comes, probability that in 10 minutes at least 2 customers will arrive, and probability that in exactly 1 minute one customer will arrive. Okay. Um, so let's start solving this question. So basically we are given a mean time interval, the mean number of probability of customer arriving in a time interval. So let's start with the what we know, what is given. So we know the number of customers in time interval 0 to 0 to t equal to k is given by e raised to minus t lambda into tk raised to into lambda t raised to k upon k factorial. So the probability of at least one customer arrive in 2 minutes is 0.3. Now we have given, since t equal to 2 and k is equal to 0 in this case, and which is equal to 0.3. No, sorry. So at least 2 customers arrive in 2 minutes, right? So one minus, so when if we have to find no customer arrives in 2 minutes, right? So we just have to subtract at least one part from 1, right? So probability of 0 customer arriving, that is in time interval 2 minutes, 0 customer arriving is 1 minus 0.3, which is 0.7, which is basic. Okay, so now we use these values and substitute in our given equation to find out lambda. So e raised to lambda into t is 2 into lambda 2 raised to 0, t is 0, sorry, k is 0, divided by k factorial, which is equal to 0.7. So I just did some calculations and found out that lambda value is 0.178. So first part we got the answer here. Now for second part, we have to find out probability that in 3 minutes no customer arrives. So here t equal to 0 and k is equal to 0 2. Okay, now t is equal to 0 and k is equal to 0 2, and so now we just substitute these values in equation. Since we have lambda and t both the values, so we can calculate our answers. So I calculated it and it comes around 0.586. So the probability that in 3 minutes no customer will arrive is 0.586. So this was easy. So for the next part, we have to find for the final probability that in 10 minutes at least 2 customers will arrive, right? Now when we have to find at least 2 customers, we can from 1 we can subtract 0 customers or one customers. So in this way we will find out the probability of at least 2 customers, which is exactly the same thing I did. So from 1 I subtracted in 10 minutes 0 customer arrived, and in 10 minutes 1 customer arrived from 1. So in calculation, so I just substituted 10 and t equal to 10 and k is equal to 0 in both the equations, and then the value came out to be 0.531. So the probability that in 10 minutes at least 2 customers will arrive is 0.531. Okay, so for the last part, we have to find the probability that in 1 minute exactly 1 customer will arrive. Okay, so this part is shorter. So we just substitute t equal to 1 and k equal to 1 in our original equation, and we found out it's 0.4149. So the probability that in 1 minute exactly one customer will arrive is 0.149. So thank you for watching my video.